All right. In this video, we're going to look at how does the prisoner's dilemma relate to oligopoly. Okay, and so we're going to use we're looking at a prisoner's dilemma. Then we're going to say, well, how does this relate to our situation? So it relates to our situation where if we have if we have this attempt to collude, increase the price, to raise prices. Okay, so they want to collude to raise the price, kind of like a monopolist, and we can use the prisoner's dilemma to model this and to show why it's actually kind of difficult to do that, a little bit difficult to do that, and then we'll talk about under what conditions can we do we get this collusion. Okay, so we're going to use a duopoly example just because it's mathematically more simple. And so that means we just have two firms. Okay, so so you could think of this as Coke and Pepsi or something like that. Some market where there's just two big firms that pretty much dominate the market. They could they could do this in their market. Okay, so we have the choices for the firms. So each firm can either keep production low or high. Okay, they can keep their production low or high. And why would you say, well, why would they want to produce low? Well, that's like a monopoly, right? So if they cut output, this will raise the price, much like a monopolist restricting output. So I'm going to have a simple example, a kind of silly one. I'll give you another one online. This is just the best I had right now while I'm making the video. Okay, so the model I'm giving you is actually from a ManQ textbook. So it's a ManQ textbook model. So Jack and Jill. So you probably heard of them, and we're looking at a water market. We're looking at a water market, Jack and Jill, and so they're both fetching pails of water and to deliver to a town. And if they bring less water during a certain day, then they can charge a higher price because there won't be as much water for the town. But people probably want about the same, so that'll bid up the price. And if they bring more water, then the price for water will probably go down. Okay, so they can carry 30 gallons, or they can carry a high amount, which would be 40 gallons, right? Okay, and then Jill has the same. Okay, so think about for a second, maybe pause before we go on. Let me look at my color scheme from before. Okay, blue and red, just so I want to keep consistent. All right, so which one's going to give them the most profit? Is it going to be low production or high production? Okay, so if you said low production, you're correct. Yes, so this one, Jill is going to get 1800, and so remember Jill is this blue one, and Jack is also going to get 1800. How I got these numbers doesn't really matter, right? Because we're just trying to have the structure. And if they both produce high, they're going to get less profit because they're going to get less profit because their production is so much that it ends up being cut between the two people. Okay, and then if one produces high and one produces low, who's going to benefit, the low or the high? Okay, so think about that for a second. So if you said the high, you're correct. Okay, so if you said the high person, then you're correct. So because the other person produced low, so the total is just going to be 70 gallons. And so you're going to be able to charge more than usual, right? But you're going to have the full amount of 40 gallons. So you're going to be able to charge more than you usually do for this, and so you're going to get quite a bit more. Then the final, so then again, if Jack does low, then and Jill does high, Jill will make more money and Jack will make less money. Again, the exact detail of everything is not that important. What is important is the structure. Okay, the structure of the game is the important part. Okay, so let's think about it. Now, walk through the same procedure. If Jack was to, sorry, we'll start with with Jack's choice. If Jill was to go low, then what should Jack do? So 1800 versus 2000. So definitely 2000 is better. So if Jill goes low, Jack should go high. And if Jill goes high, Jack should also go high. Okay? Because if Jill goes high, it's going to push the price down. And if they push the price down and you produce less, you're going to obviously make less money, right? So you might as well at least produce more so you can get a little bit more money that way. Okay, so that's the idea. Now, if Jack goes low, so Jack chooses low production, Jill will choose high, right? That's going to push the price down, doing low for Jack, but then you can then scoop in and like sneak in and produce high, and you can make more money because they push the price down by going low. And then if Jack does high, then Jill definitely should do high. Okay, so again, this ends up being the Nash equilibrium. So this is our Nash equilibrium. Same idea as with the prisoner's dilemma. Okay, so the cooperating equilibrium of low is hard to hold together. And that's the insight this gives us. That's the main point of what we've done here. Okay, so the cooperating equilibrium of low is hard to hold together, and the reason it's hard to hold together because let's suppose you say, okay, let's both not bring much, let's both produce low today so we can make more money. I say, great. And then what are you going to think? You're going to think, okay, they're producing low, so now I'm going to go high. This is the idea, right? This is the basic idea. They're producing this thing low, so I'm going to go high. This same kind of tension happens in, for example, oil-producing countries that are part of OPEC. This same kind of tension happens in, for example, oil-producing countries that are part of OPEC. They want to keep the price high, and they do this by all the countries cutting their production, right? But once the price is high, then there's an incentive for some countries to cheat and produce a little bit more. When I say cheat, I mean cheat on the deal. I don't mean, it's not really cheating, but it's cheating on the deal they made with these other countries, because they can make extra money by doing this, right? Because their extra production is not going to push the price down very much, and they're going to be able to collect a lot more money from doing this, right? So there's always this strong incentive when you have a group of businesses colluding. There's always a pretty strong incentive for one business to break this cooperation. So usually to hold this together, they have to have some kind of deal, and they also have to have some kind of way to punish the people involved in the deal for this. You could think the same idea. It's the same idea if you think about a price war, where if you cut your price, you want to both keep the price high, but then if the other person's price is high, you want to cut yours to steal their customers. But if they think you might cut your price, they also want to cut their price. And so anyways, you end up going from a situation where you would like to both keep your price high, but in the end you actually both cut your price to steal the other customers, and you end up with this equilibrium that's pretty good for the customers, but not very good for the companies who are trying to collude with one another. Okay, so that's the main idea here. Is it this model can be used to show why colluding with another firm can be difficult.